Well, hello again. Before we start getting into the actual change-up of things inside the chassis, I was getting ready to, install this terminal board here, this terminal strip here, to put a 20,000 ohm 2-watt resistor on there. Incidentally, it is 2 watts. If I'd read my documentation a little closer, I might have seen that, and I now know the wattage of every single resistor in here. There's a very clear picture of it, but it was very, very smudged and everything, and I just never bothered to blow it up. But once I went to the internet and blew it back up again on Nostalgia Air, I could see that this was a 2-watt 20,000 ohm resistor, color-coded red and black. So what I decided to do was tear it apart and show you kind of something interesting. You know, we have the carbon film resistors and we have the carbon resistors. Well, Atwater Kent, he took carbon to its ultimate destiny here. It's once you remove the cap from each end of these things, you'll see 2 little holes. I don't know if you can see those holes. Let me see if I can zoom in a little bit. See the little holes right there? There's one on each end. Well, what those holes are there for, let me stand this thing up. Well, I can't do that. They got little pencil lead things. It looked like just old pencil lead that came from one of those mechanical pencils. They're made out of carbon, and they slide down in the holes. Yeah, those 2 little holes, just like that. Just like a pencil lead. It slides all the way down through to the other end. And then it comes out if you're not careful. Anyway, he slid those in there. I don't know if he did that or someone else did it. He may have bought them like that. Whoever made them like that. They go in there like that. And they give you, the amount of carbon determines the amount of resistance. And then they soldered this cap on. Can you see? Let me get a lamp over here. I don't know if it's going to help or not, but we're going to try. See that carbon sticking up out of there? They soldered it in there. This is actually made out of solder. This cap is made out of solder. That's why it was so easy to solder. That's really slick. But that little carbon tip right there, sticking up out of there, goes in those 2 holes. And he soldered one on each end. Well, that's pretty slick, isn't it? You better believe it is. I had never torn one of these apart. Just 2 carbon rods. Almost like a little nuclear power plant there, huh? Alright, I learned something today and I hope you did too. I've got the terminal strip in, and I just set the 20,000 ohm 2-watt resistor in there like so. I bent the leads. I'm not going to put it right up against the terminal tabs. I'm going to kind of keep it away just a little bit. And then later on, of course, once I solder it in, I'll cut the leads. Now we have to figure out, we've got, here's the original 1/2 of the resistor with all kinds of wires and stuff hanging to it. So we need to figure out, it'll be going right there on that part right there. And the best part about this terminal is I can solder it here, put my wires in that I need to go on each side of the resistor, and I still have a terminal left over on each end that I can use for other things. See? I just have this one left over and this one left over down here. Okay? This thing will probably come out. All of this will be removed, and I think this resistor will probably go. I haven't tested it yet, but you can pretty well bet it's bad. So what we're going to do is I have to cut some wire. So let's take a look at our schematic here and find out exactly what I have to do. And I'm going to show you how this is done, so it's not that difficult, okay? Let me get my camera situated here. Now you remember we had a wire that came off of pin 3 of the 2A5. And it came on down, all the way down, and it came across here, and it went up to one side of that R14 resistor. Alright, here's the piece of wire that I have cut to do that. This wire right here. It's a white wire. It will run from 2A5 over to the resistor like that. Okay? Just like that. I'll remove the old wire and solder a new one in and run it down close to the chassis. I made sure the wire was a little bit longer than it needed to be. Don't get chintzy on your wiring, Make your wire a little bit longer. Get it down there next to the chassis to prevent any kind of hum or anything of that nature. And then if you get it all done, it's down close to the chassis real good, and you bring it up and solder it in, you do have a little bit left over, you can go ahead and shorten it then. Don't get chintzy on the wire. I mean, the wire doesn't cost really that much. Alright, then that takes care of that wire. Okay, the pin 3 on down is taken care of. Now I need another wire here. There's a junction right there. This one goes down to the electrolytic capacitor. So that's a yellow wire. So I'm going to cut myself a yellow wire right there. Let's do that. Now C19 is this capacitor hole way up here. And we need to go from the terminal strip up to C19. I want to give myself plenty of wire, so I'll just cut it like that, okay? So now that's covered. We got that pretty much covered. And that'll slide down underneath like so. Put it down under there. And then stick her there. Anyway, let me get this baby up here to kind of give you an idea what I'm talking about. Okay, now that'll go there, and the other end will go up here. We have one more wire to run, and that's from that side of the resistor down to the speaker plug. But we're not going to be worrying about that right now, because I'm not going to hook the wire up. This is the wire I'm talking about. It runs over to the speaker plug, as you can see, but the speaker plug's all busted to pieces. We're going to go ahead and convert this thing over to a permanent magnet speaker, so we're not going to be using a speaker plug right now, unless I can find one to install, and even then we won't be using it with a plug, because you know, the permanent magnet speaker will just have the wires, not the plug. So what I'm going to do is it's connected to pin 3 of that 285. They just ran it from there over to there instead of running it from the resistor over to there. You know, saved wire and time and energy and everything. So what I'll do is I'll go ahead and just disconnect that and get rid of it, and then we'll be good to go. We just need one white wire and one yellow wire going over to the ECAP. So we need to get that done. The first wire has been soldered. The white wire has been soldered to pin 3 on the 285, and I've got them all. The rest of them are sitting in the hole right there. I haven't soldered them in yet, and I have run. You'll notice the wire is down close to the chassis all the way. And this one here is also close to the chassis all the way. Gave myself plenty of room. Now every time I do soldering or wires manipulating in a chassis or any kind of stuff like that, someone always asks me, what size wire do you use? I use 22 gauge hookup wire. Now if the wire needs to be flexible, use stranded wire. If the wire is rigid and does not ever move, you can use solid wire. Just don't use solid wire where you need flexibility, because that wire will break off. Okay? And so what I'm going to do now is go ahead and solder those right there, and then we'll see what I've got to put on the other end of this resistor. Let's get these soldered up so everything is kind of, you know, rigid and held together. Everything is now soldered in place right here to one side of this resistor, to this one side. I'm going to get the pencil off of there. Pencil eraser on there. Alright, everything is soldered to one side. Now that should just about take care of it. So what we're going to do is we're going to take our old marker. This is the way I'll be doing the rest of the wires all the way through, one by one. We're going to take the marker. We got this wire in place right here. We're going to come down, 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 down. We're going to show it all the way across. Oop, that didn't come far enough. Come down, 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 all the way across, go up and there. We now have that wire connected. Now to the from the ECAP, we're going to come up, and we also have that wire connected. Okay, so that should just about take care of it. We do not have this little piece of wire connected right here to the speaker plug, and that should do it. So let's see what we've got. Now we ought to be able to take out all that old stuff. So this is what we're talking about. Pick it up. Oh, uh-oh. Uh-oh. We've still got another wire to figure out where it goes. And son of a gun, we got another resistor here too. Look at that. A red and yellow. What is that crap? Now this wire here goes over and connects to a maroon. Maroon and a red and yellow. Let's find out what that's all about. This is the way you gotta do it, guys. Alright, I have an answer for you. The maroon resistor, right here on this board, is R2. That's R2. And R2 on the schematic is right here. So let's follow R2 back. Follow back, all the way across. Yep, it goes back to the one side of R14. Son of a gun. Now this this little red and yellow one. One thing about Atwater Kent resistors, they look orange a lot, so you have to double check the color. That's actually red and yellow, and it's hooked to that side of that cap on that resistor too. Let's find out what red and yellow is. Let's see. We've covered this line here, and we come up here, and there it is, red and yellow. Red and yellow. It's that's 0.25 megohms. This one here, R2, is 10,000. We need to measure those. Alright, this is supposed to be 10,000. I've got one side of it hooked up with an alligator clip to my multimeter, and then we got the other one. Let's go ahead, and I've got my scale set to 20,000. Let's see what we get, what kind of reading we get when I touch it. Nothing. Nothing at all. Let me open up the back of this thing so it sits a little more of an angle. There we go. We got nothing. Well, that sucks. Let's go a little higher. Nothing. Let's go a little higher. Nothing. Let's go down here real low. Nothing. Guess what? We have an open resistor right here. That thing is no good. That's going to have to be replaced. R2 is bad. Alright, that's that baby right there. Now let's come over here and go up here and check this R10, which is that little one right there. Let's go ahead and hook an alligator clip to one side of it. Now this is supposed to be 0.25 megs. I'm going up to the 20 meg scale right here. Actually, probably I could get by with the 2 meg scale. Let's see what we get with that, if anything. Nothing. Let's go up to the 20 meg. Nothing at all. Are we even getting continuity here? Yeah, we are. My God, something blew these things all to pieces at one time. Let's try the resistor body itself. Well, apparently this one's no good either. Something wiped out this entire bank of resistors. Must have, as you can see, it's pretty black down in there too. There's a lot of blackness. Maybe it took a lightning shot or something. I don't know. Who knows? You know, who cares? Who cares? We're going to replace that resistor too. 0.25 meg is bad. Alright, I'm going to stare at this schematic and see if we had any other resistors that we might have missed. And if we do, I'll come back and tell you about them. Well, there was one more. Coming off of R2 and going up here is a green and red resistor, R4. Now, according to our little handy-dandy drawing over here, R4 is the third one from the left. It's green and red. 1, 2, 3. There it is right there. Now I've got my multimeter hooked to it. It's supposed to be 3,300 ohms. I think. Let me double check. Yeah, it looks like 3,300 ohms. Hard to read. Let's go ahead and see our meter here and see what we get. I'm going to go ahead and read this one. Maybe we'll get lucky for a change. Alright, it's up past 4,690. That's too high. Well, I'll tell you what. I'm going to make a command decision here. Let me tell you what the command decision is. The command decision is I'm going to change every one of these resistors out. We're going to get rid of this junk and put in some good stuff. And the next time you see this chassis, all of these resistors will be changed. So meanwhile, I am going to take and get rid of some of this other stuff that we don't need. Let's get rid of that. I love chopping and cutting. This is great. And kind of leave this other one out of there. We'll get that one out of there too. Kind of give me a little bit more swing room and everything on this. Okay. That's it. I'm going to wrap up this video with that. And that's exactly how I plan to go through this entire schematic. Wire by wire by wire. Using the paperwork I have, the schematics, the pictures right here, and what I've got in the chassis. And if I run into anything really weird, I'll come back and let you know. But that's going to be the end of this video, and next time you see it, I hope that it'll basically be nothing but progress reports until I, get it all wired. And I do want to come back and work on this local oscillator coil. It needs some cleaning, but we'll get to that later. So until next time, I hope you learned a little something here. I try. You know, my camera's not the best in the world. I give it my best shot. I just want you to understand, do not be intimidated by this stuff. It is not that complicated. A monkey could do it. All you got to be able to do is follow a line on a paper, and then go up here and find the line in the chassis. Piece of cake. This is John.